Hi, I'm Maribel Lopez. I am the founder of Lopez Research. Panelists, come on up. So I'm the founder of Lopez Research and also the founder of Data for Betterment, which is a nonprofit organization that helps companies figure out how to move forward in the land of AI and giving them information about career change and other things in that area. And I could think of no better thing to do than to be here today talking about culture and organization and how to do things like effectively have machine learning at scale. Everybody have a mic or no? Yes, there's one missing. Here. There we go. Great. So without further ado, I'm going to jump right in it. You know, one of the things that we're seeing with organizations is that there's a tremendous amount of talk about artificial intelligence in organizations, not necessarily a lot of companies or executives or line of business people actually really understanding what that means, how to do it. Sometimes it's like, I'm just going to go out and buy something with machine learning in it and see how that works out. So one of the challenges I think that all of you in the organization are facing is how do we get the different groups in an organization to effectively work together? So if we look at this, if you have a data science team, data engineering, how do you actually work with line of business managers? How do you work with the C-suite so that you can actually get to delivering business value with AI technologies and tools? So I thought that might be a good first place to start as we're talking about culture and organization, because technically, you probably can't decide what kind of organization you want to switch it to, centralized or decentralized, but you will have to try to make this effective and efficient and delivering business value. So maybe we could start there. Maybe we will start with Jennifer. You want to give us a few points or tips or how you've seen this work in terms of talking to the different groups within an organization?
Yeah, no, I saw, as you stated before, completely agree that this is certainly like probably a bigger challenge than the technology itself, right? So the first thing I would say is, like, first of all, I have very good news. It's that there is a very easy way to solve the way you communicate with the C-suite or product management, and that is by educating the people you're gonna communicate with. And the easiest way to do this is to go all the way to an MBA program and teach them and basically prepare the next generation of leaders and product managers to be ready to interact with people who are going to handle machine learning research and machine learning product, right? So we're basically in survival mode right now. It means that we have to figure out a way to make it until this next generation of leaders comes in place, and these are actually the people we're either reporting to or working with, right? I mean, so in the meantime, obviously there are different segments, and so to me personally, like one of the biggest challenge I always had was like define what product management means for machine learning. But that's a long story probably.
Okay, we're going to circle back to defining what project management means in machine learning in a second. Eric, maybe you have some thoughts on this.
Well, sure. Well, I think one thing you can do to align yourself with the C-suite is you can become the C-suite. So at Stitch Fix, we do have a special arrangement. I'm the chief algorithms officer, an officer of the company. Up there, peers with the CFO and CTO and so forth. So that does help change things. It's easier to get alignment as peers rather than somewhere buried down the org structure. And it being at that level, it changes a couple things. Is one, you have to be accountable. And if you're accountable for your own things, people stop bothering you. Oh, sorry. With officer representation, what happens is you become accountable. You're not a supportive team to other folks. Instead, you have your own goals, revenue goals, or other metrics, right, that you are accountable for, not supporting another team. And so that changes things dramatically on how the company embraces data science. And the other thing that happens with officer representation is you get influence. You can influence the way companies work. And you can do away with the notion of big ideas, and instead companies have hypotheses that are put to the test. And once the company learns after a short period of time that they're wrong a lot, then they start to change the way they do even engineering, where they're not going to build a certain feature. They're going to build a general platform to try 100 features, because Lord knows the first one's going to be wrong, and you need to iterate and do things a little more generally. So that's one way to go about it, is if you get the actual officer representation, and it's, I'll be honest, it's a much easier way to do it than to try to manage it from down below. So if you're fortunate enough to be in that situation, it actually is something I highly recommend.
Now, I know, Pardis, you actually are in a company that has a lot of data behind it and a lot of data science behind it, but there's also a lot with the marketing organization and sales. So how have you looked at approaching this problem in your organization?
Absolutely. The way I approached working with sales and marketing is kind of the same way as I think about data science working with these various product teams. Nowadays, you have continuous integration, and you have online products in the cloud. So products are being launched almost every day, and product is changing every day. Because of that, the way data science is working with the engineering teams needs to be fully integrated, looking at every feature launch, every experiment, every kind of change in order to make sure that the data reflects that, and we're accounting for it in building our models, updating our models, and so on. And so is the same with sales and marketing, because in the past there were like various versions of, let's say, a product, Windows 95, and the specifications were already made clear. There was enough time for sales, marketing to understand what the market would be like, but also be able to fully understand the product to go and sell. Now that's changing. The product is changing so fast. In order for sales to know what to sell, they need to be as integrated within the kind of product as much as possible to know exactly, okay, this kind of part of the real estate on the app is going to be 1/10 of what it used to be, so we need to communicate that to our partners. Or the targeting algorithm will change, and so this we're actually going to bring in 10 times more traffic to your product, and so sales could kind of be in the loop for that to be able to communicate that to the partners, and that's how we can like set marketing and sales up for success.
Excellent. That makes sense. Having that data and insight to know what's going to happen next so that they can plan and make changes to their model is important. Now, we had a session earlier where Levi's was talking about some of the things that they did. So that's a long-standing established company. Jennifer, I know that you actually have done some work with Walmart in the past. Have you seen any differences in terms of how to think about that? They're a company that's had a lot of data, that's been working with data for a long time. Did you see a change happen over the course of the time that you worked there in terms of how they worked with it?
So when I joined Walmart, actually, so one of the big change I had to provide to the companies, like I think, and you were talking about integration earlier, right? I mean, so something I also would like to state here is that I think one of the biggest challenge like a machine learning team is going to have is lack of integration with engineering, right? Because if you do have that integration, it puts you in a position where you are fully responsible for what you're building, right? I mean, so it's almost like you do some machine learning research, you can create a product with it and prove to the C-suite and the rest of the organization that this is actually going to provide money for the company, right? So before we talked about Walmart, I would like to state something else that's actually pretty interesting. So I was lucky to have both, like I managed like machine learning at Atlassian, and I managed machine learning at a smaller startup, Figure 8, right? And so in both cases, we have the different structure. So for Atlassian, for instance, I was really lucky to have like the opportunity to build the entire team from scratch, and basically I brought in like basically 50% of the team was engineering, right? I mean, so it meant that the algorithms we were building, we were actually able to create and fully prototype on our own, and it was much easier to push this to production. Now we had other challenges related to the internal organization within Atlassian, where you had to push that into specific products, but at least there was a prototype that could exist, right? By a position when I was at Figure 8, like my team was 100% machine learning scientist, and this is something I had no control of because the team was already established when I joined, and unfortunately, basically, like we were like constantly frustrated that things would not go to production because there was no engineering that could actually engineering team that could bring these things to production, right? So that brings me back to Walmart, right? I think one of the challenges, the companies like a few years ago did not necessarily have this understanding that a machine learning team is not an engineering team. They don't think the same way, they don't function the same way, and a machine learning scientist or data scientist is not trained to write production level code and push this to production, right? And so, and basically, this means you have to rethink the organization, right? I mean, so at Walmart that was a huge challenge because when the machine learning teams started building new algorithms, for instance, and in particular when we know that because we are machine learning people, we know that models need to be retrained on a regular basis, but the C-suite, except if the C-suite is a machine learning scientist, does not know that. Like, you would be surprised the number of people like, hey, you created this algorithm, why do you have to retrain it, right? And yes. This is not something that's, and so this is where machine learning lifecycle management is something you have to push onto the organization if you want to be successful.
Yeah. I actually think this point of machine learning lifecycle management is a huge issue and largely under-addressed in our communities. So, Eric, do you have any concepts or thoughts around either a full stack or lifecycle management?
Well, yeah, I have strong opinions on the full stack thing. So, the team at Stitch Fix, we built to be to avoid what we call handoffs. We don't like when, say, a research scientist wants to do some modeling, so they partner with somebody called an ETL developer to get them the data, and then once they find the model, they have it trained, they hand it off to a machine learning engineer to implement it. And then they also might employ an inference engineer to measure it, right? So all that is fine and dandy, but it requires handoffs between that, and that slows you down. Handoffs are appropriate when you know what it is you're building. Say if you're manufacturing something, you've got it, the requirements are crystal clear down to the millimeter of precision, then you can specialize and do those handoffs. But when it needs to be iterated on, you're not clear what it is you're building or learning, then I really prefer to have it in as few hands as possible, ideally even sometimes one full stack data scientist that can do all those parts, do the ETL, do the modeling, implement it him or herself, and set up the A/B test appropriately to measure it. That's ideal because that person can move as quickly as possible with no handoffs. So, and again, the benefit of the goal in data science is to learn something, to implement some new algorithmic capability, preferably that makes a lot of money, but to learn it, to figure out how to do it. It's not to do the fine tuning, not to do something more efficient or just to skim a few pennies off of something. It's usually to do something big and profound and something that was new to the company, a new capability. And that type of thing, usually with data products, you can't design it up front. You need to learn as you go. So you have to design the team to enable them to learn as they go so they don't get caught up in so many handoffs. So that's the thought on the full stack data scientist, as we call it at Stitch Fix.
Yeah, so what I like about this is it highlights that there are different ways to do it, but you have to be very specific about understanding what are the different levels that you need and who is going to take care of those different levels. And I think if you're lucky enough and you can find full stack people, that works great. If you don't have full stack people, you need to know how that you're going to break this up so that the right people are doing what they're skilled at, but that they're coordinated enough to make that happen. Pardis, any thoughts on your side?
I guess the only thing I would add would be around the fact that the data is always changing because, as we spoke before, the product is always changing. It's also the fact that, sometimes company strategy might be changing, and so you'd want to update your objective functions and accordingly. Another thing is the data could change because your product is growing so fast in additional markets, and suddenly you have users using the product in a completely different way if you're lucky. And so all of those various factors kind of change, your product completely. And so you'd want to have people, providing always on support to be able to make those changes and updates as soon as possible.
Yeah, that makes sense. So I'm going to circle back to lifecycle management, and maybe we can go down this way and just talk a little bit about what you think is or isn't happening there and what you think needs to happen there. So Eric, why don't we kick off with you?
Sure. For lifecycle management, so the process I just described earlier is about an initial implementation of some new capability. And that's what I think goes fastest without the handoffs, without the specialization. You have more of a general full stack data scientist. That said, once it's in production, supporting it is hard, and so you'll probably need some help. And in fact, that's something that's often unintuitive to folks, either from the business side or engineering side, is they think that resources will roll off a project once it's implemented, and that doesn't happen. You increase the number of resources you put. So if something is successful, a new recommendation engine or something, and it's live now, it's not like you deploy those people to go somewhere else. No, they double down on it. They have their best ideas come after implementation, and they can get better and better algorithms in there by testing them against each other and making successive changes to them. So you end up usually increasing, not decreasing after implementation. And then the support stuff is problematic. It becomes more of a burden than actually building the thing. As you mentioned, data changes a lot, and it could wreak havoc on your stuff. A new engineering feature goes out and isn't compatible with your algorithm. Things need to be adjusted and changed pretty constantly. And that's when again, it might take one single person to implement the capability, but you need to start staffing up that team to support it. As that person eventually wants to take a vacation now and then, right, and doesn't want to be left supporting from wherever they go on vacation. And so you need to add resources later, and that's something that needs to be kind of explained and anticipated. But we do a kind of a tough thing at District. We wait till it's successful and then start adding the resources. So it's always a scramble, because a lot of things do fail, and you don't want to set up people, hey, you're going to support that thing once it's in production, but it never gets to production. So you end up in this game of catch-up by design. We consider it as the lesser of the two evils. But you do have to plan as best you can that, okay, if these things are successful, we've got to get ready to staff up to help support.
All right. No, I mean, so going back like to the example with Walmart, right? I mean, so actually when I was at Walmart and we had like more and more models coming out to production, so I actually started surveying my team for basically ask them like for every like a new model that's coming in, how much more work do you have? And so after I surveyed my entire team, turns out that when we were like basically like in periods where the models had to be retrained frequently, for example, close to Black Friday or this type of periods, or close to Christmas, people were spending like almost 75% of their time retraining models, relaunching things, because there was no pipeline to do this automatically. So actually, like one of my my pushbacks on management was like, we need like a way to systematize the way that you actually like deploy and retrain the models, specifically in an environment where you need to retrain models every day. Like it's very typical for e-commerce or similar spaces. I'm sure it's true for social media as well, right? And so eventually what I saw as being a problem, so I almost had the reverse problem at some point where it's almost like you have to think about like what really lifecycle management means, like when I'll come back to this later, right? But when finally I convinced the company like we need a systematic way to retrain this, like using technologies such as Airflow to keep things going even after you move forward, then the management team almost had the sense that the model is taking care of itself, right? I mean, so it's going to be retrained fully automatically. And so this is where I think people are missing the point that in life cycle management, you have life cycle management. So cycle is, and this is actually kind of important because to me, cycle means feedback, right? And so there is a huge missed opportunity when you try to fully automate this, to take the feedback of the model you've trained and basically understand the failures, the reason why, you didn't reach 100% accuracy, and feed that information back into the system, right? And so I think it goes back to maintaining in the long term, right? I mean, a model and fixing the failures you had at first and so forth and so on. And so I think it's also important to see lifecycle management as being an opportunity to get your model in a better place, not just keeping it up to par or up to speed with the current data.
Definitely, yeah, 100% agree with with that, just because so many things are changing around the model, whether it be like sometimes there are policy changes, and so the way you're labeling your data will change, and you will need to then think about your model differently in that kind of space. Again, the way that you will be, your objective functions might change, and the users might change as we talked about in a different geography and things like that. And I also wanted to also reiterate something that Eric was talking about around kind of headcount, and the fact that if something is successful, you will need more, not less, people to kind of work on that project. And so if something is a high priority, a lot of times you would hear, could we just borrow 1 or 2 data scientists to kind of think about or opportunity size this project? And it's usually, well, if this is going to be a priority, we need to think about long-term data science support for this data product.
Yeah, I think the one thing that you've heard a lot that you should really take away from this is that, because of some of the marketing messaging that's gone out around AI, people do think it's very automated, and that once you get something, that it does just take care of itself. And that is something that you really have to get ahead of, because this concept of resources for whether it's new software or tooling so that you can create a more automated retraining pipeline flow, or whether or not it's actual more headcount, this is going to be a thing in the culture and organization discussion that you definitely have to get ahead of. I remember talking to one bank that did not realize that they were, they spent a long time going through their model, and it was in the chatbot section. And they had to retrain it every day for a very long time, because they didn't think that, well, people don't speak in terms such as activate my card. It's something a bank would say, not something a human would typically say. You might say, turn on my card, or some other variant of that. And those types of, feedback loops and interesting learning meant that it takes a very long time, a lot longer than people think, which means also that programmatically, you probably have a pipeline, and your pipeline's going to take a lot longer to get through than your management originally thought. We have about 3 minutes left, and I was wondering if there's one question in the audience that anybody would like to ask. If so, want to raise a hand, stand up, or anything? Hold on.
Thanks. Yeah, great talk about educating the whole company about how building ML machine and AI product is. I hear a lot is some solution is to hire different people into the team, so the team actually have different kind of knowledge, they can help each other out. I think there's another dimension. I wonder what's your take is, there's a whole company. You can't solve all the problem. Like, you need data. Are you going to build the entire data lake yourself? Are you going to build the entire computational layer for yourself as well? How would you educate the almost like it takes a whole village to build it?
Is that directed to me, or? But you're right. I mean, there are certain parts of certain capabilities that the data science team is totally autonomous for. But most things, you're partnering with somebody. They're sometimes with marketing or merchandising or other teams, and it does take a village. You need a lot of it, and a lot of times integration with engineering. But because data science works differently, right? Much more iterative and much more uncertain, inherent uncertainty in what it is we're building and what we'll find and what becomes significant. You have to plan for that iteration. And since it's the data science team that works differently from the rest, what we've done is we've made it incumbent that we build the APIs that engineering will integrate with. They call the APIs, and that abstracts us, right? We're now behind an API that they're going to call, so we can change things and test things as much as we can, and we don't need to coordinate those, right? Because they're just calling the same API before. So little tricks like that really help to decouple teams, and yet still work together. We have to be aligned on the goals of what we're doing, and then when we work with marketing and merchants, for example, there's no APIs for buying merchandise or for making new creatives. So those are more of a formal relationship that you have, and you want to blend both of their experiences. You get some of the domain expertise from marketers and merchants, what they know, and then also get what the data's telling you, which are sometimes very complementary or different or even contradictory. And both together are usually much better than any one on their own. So
any other comments?
No, so what I was going to say, so you actually like a similar comment to what you just said, right? I mean, I just would like to build on top of that. So at Atlassian, we had like a similar kind of model. So we actually like the data science / machine learning team was under the platform department. And so basically we're like a team that would service the other teams. And so similarly to what you said, like we had like either APIs and we're like basically in charge of building a model, right? So I think something that's very important to note here, and I think like not specific to Atlassian or any company, right? There is like really like machine learning research and there is machine learning product, right? And so for instance, like I can imagine a company in which you have like the machine learning team, the deep down machine learning team that creates, let's say, an OCR model. And then there is a product or an applied machine learning team that actually applies this model to create cool new AI products, right? And these don't need to be the same team, right? I mean, that's almost the way that I see that. It was actually pretty successful to do that at Atlassian because we would empower the rest of the organization of integrating AI in their own products, even though there are not AI engineers or machine learning scientists themselves.
Closing comment, Pardis?
I think one aspect of being able to get buy-in, to get more support from engineering on, let's say, issues of data quality or building data pipelines was to show kind of the impact and the fact that they could move faster if, through that collaboration, they would be able to ship with more confidence and kind of showing that over a couple of
Doesn't slow them down, but speeds them up.
Exactly.
Excellent. So with that, thank you for your time and attention. We're finished.